In this presentation, we are going to test a hypothesis where this time our focus is going to be on the average to figure out if there is a significant difference in the average between two data sets. So in the example that we have here, the question is, at 5% significance level, test the hypothesis that there is a significant difference in the mean sales, which the mean represent the average sales revenue between 2019 and 2020 sales data. So here we have 2019 sales. We want to figure out if the average for 2019 sales data is significantly different from the average sales in 2020. To do this, we need to come out with the null and the alternative hypothesis. The null hypothesis will state that the average or the mean sales in 2019 and 2020 are not significantly different, meaning that the average for the two data sets are basically the same. The alternative hypothesis will have it that the average sales in 2019 and 2020 are significantly different, meaning that they are not the same, they are not equal, and they are far apart from one another. Question B asks for justified your choice of the statistical method, and the choice of method will be t-test. So we're going to use the t-test assuming equal variance, right? The t-test because the population standard deviation is unknown. We don't have any value, or the population standard deviation is not given. What we can derive is a sample standard deviation because we have a sample data. So given that the population standard deviation is not given, we will use the t-test. Now we are going to assume equal variance because we have, from the previous example, the variances between these two data sets are essentially equal because we conducted a test and the test proved that the variances are equal, and that's the conclusion that we derive from that previous test, meaning that there is no significant difference in their variance. So in that regard, it means that the choice of statistical method that we required will be a t-test for the reason that the population standard deviation is unknown, and we are going to assume equal variance for the reason that the sample variance are not significantly different, they're essentially the same. Now determine the tail test. To make a determination of the tail test, the two tail test will be used because the alternative hypothesis is seeking for the difference between the two hypothesized values. Because of our alternative hypothesis is seeking for difference, the difference could go either way. In that case, we'll be looking at the plus and the minus, or the two-tail test, to come to that decisions. So the two-tail test will be used in that regard. Question D asks for establish the critical value, and question E asks for find the test value. So this is where we have to run our Excel and come out with the results for the critical value and the test value. Excel does this, and you don't need to do any calculations manually to derive this. So to do this, we go to data, select data analysis, and now we look for t-test because the method that we have to use is going to be t-test. Now you notice that we have t-test to sample assuming equal variance, and we also have t-test to sample assuming unequal variances. Now, as we decided that we have to use equal variances because in our previous question we came to the conclusion that the variances between the two data sets are essentially equal. In that regard, we have to use the two sample assuming equal variances for the t-test. Over here, the first variable range, we select our first data. For the second variable range, we pick on the second data set. As the cursor blinks in the box, we go ahead and select the data. Always make sure that you include the column header, the descriptions, in your selection. And then what is the hypothesized mean difference? Our null hypothesis stipulate that there is no significant difference between the two data values, the average of the two data sets. So if there is no significant difference, then it means the difference between the mean should be 0, right? That is what a null is stipulating. If the average of the two data sets are equal and no difference between them, then it goes without any thought that the difference should be 0. So that is why we have to put in 0 as the mean differences between the two data values. And then we check on the labels, because we've included the labels as part of our data. So Excel can detect that the first row represent labels and is not part of the data. Our alpha is going to be 5%, which is the default. So 0.05 represent 5%. And then we select the output range, click on the box. As the cursor blinks in that box, we select anywhere where there's a blank spot to ask Excel to display the data in that spot. And we click OK, and we have our results. Now we're just going to expand this a little bit because Excel squeezes, it all looks squeezed, so we just have to spread it out, hold the cursor and drag it, and then it expands on that cell. Now we have 2019 sales and 2020 sales, right? So this is the average sales for 2019, and for 2020 that's the average sale. So we're trying to figure out if there is any significant difference between this average value. Are they essentially close enough to be equal, or they are far apart to be significantly different? Those are the two hypothesis test statements that we have. Now in order to take a look at, we have the degree of freedom, we have it as 38. We have 20 observation for 2019 sales and 20 sample size or observation for 2020 sales. So that gives you a degree of freedom of 38. Now the critical value here, we have two critical values. Excel provides you with a test value, which is t-test. So that's the test value. Now we have two critical values. The first T critical value for one tail, and we also have T critical value for two tail. So what Excel does is Excel gives you a critical value for one tail and two tail, and then you have to make the choice as to which one is applicable to your test, right? In this case, we are looking at two tail test because our alternative hypothesis is seeking for significant different because that is what the question is asking you to come out with. Test the hypothesis that there is a significant difference in the average sales between 2019 and 2020. And because differences could go either way, right, that means a two-tail, right? The question did not ask for if the sales in 2020 is greater than the sales in 2019. In that case, we will look at one tail. But since we are looking for just differences which could go either way, that means we have to look at a two-tail test. In that case, the correct tail test that we need is this one. So we have to basically take out, this is not the right one, so this is our critical value. So our critical value, the T critical value, is 2.024. So again, we have to reduce this to a 3 decimal place, and then it also asks for find the test value. The test value is given as negative 0.599. So let me just reduce. So that takes me to 3 decimal will be negative 0.600. Now, something else I need to remind you here is that because we are dealing with two-tail, it means our critical value of 2.2024 will be a plus or minus, because on the negative side and the positive side, on the right side will be positive, on the left side will be negative, because we are taking a look at two-tail. So the tail to the left will have a negative 2.024, and on our right we'll have the positive 2.024, right? So what that means, if the test value falls within this range, then we have to accept the null. However, if the test value happens to be less than negative 2.024 or happens to be greater than positive 2.024, then we have to reject the null. In this example, you notice that the test value falls within this range because the negative 0.600 lies within this critical value range. In that case, we have to accept the null hypothesis. So the null hypothesis is valid. That means the average sales in 2019 and 2020, when compared, the average sales are not significantly different. They're essentially the same, and that is what a test of hypothesis is involved. We've come to the conclusion as to which one of these hypotheses is a valid statement. We don't have any sufficient evidence to reject the null, so that means our null still remains valid, and that is the average sales in 2019 and 2020 are not significantly different from one another. Now, this will be supported by our p-value, right? Our p-value is also stated. There are two p-values given, the p-value for one tail and the p-value for two tail. Since we are dealing with two tail, this is the correct p-value that we should be looking at. So we have a p-value of 0.552. 0.552. Now we have to multiply this by 100 to put it in a percentage. So this means that if we should decide, suppose we want to reject the null, then that means we'll be incurring 55.2% error in that decision. And this error rate is too huge and exceed 5%, and that explains why we should not reject the null and that we need to accept the null hypothesis, because our p-value is greater than our significant value. Our decision will be to confirm our decision to accept the null hypothesis. And this is basically the steps involved in conducting a hypothesis test comparing the average of two data sets.